Hello, hello. Today we have Mounir Izallalen, the Strategic Alliance Manager at Eastman, and also a board member with BPI. Mounir, I've been so excited about this conversation because I come from the cellulosic world, but I'm very far removed from the cellulose acetate world, which is obviously an adjacency, but it's always such an intriguing domain. So thank you so much for joining in and being open to having this conversation.
Well, thank you. I appreciate the opportunity. And yes, we can talk your ears out about cellulosic. So very excited about this opportunity and, the chance to reach out, to a diverse set of audience. So looking forward to the discussion.
Super. And just before we hit record, we were talking a little bit about your growing up in Morocco, but I want to learn more about that. I want to learn more about Mounir the person before we jump
Yeah.
into Mounir the scientist, So it'll be great to hear, your growing up and what were the influences that you had, and especially leading up to now a very prominent career in something which is, compostables and really changing the face of the world. So how did this whole transpire, and were there early influences that you can think of that made this journey happen?
Okay, good question. Well, I still think that I'm still a child at heart. I mean, I don't think there's much of a difference. Still the same dreams, same fears, same, everything. But I grew up in the city of Rabat in Morocco, beautiful city. I went to a good school. My parents allowed me. They were very nice in giving me a chance for a good education, and yeah, I grew up in a very middle class environment. So my childhood playing soccer with friends after school was always amazing. It was the best part of the day. I liked going to school. I always liked science. So from early on, I felt I have this attraction to biology in general, and that continued to be basically the lenses through which I see everything that I have done, from the schools that I went to. I mean, like the research that I've done at the university level of postdoc. But yeah, I enjoyed. I was a very happy kid. Had a lot of friends, and living in Rabat had the advantage of having the beach nearby. So we spent summer days just being beach bums, at the beach basically. So that's something that sometimes I miss living here in Kingsport, but I go there on a regular basis. So yeah, that about my childhood. Did my I mean, from an influence standpoint, definitely my father has been a big influence, and did my undergrad in Morocco, and went to Quebec for my grad school in microbiology. So I would imagine starting somewhere around my sophomore year in college, I really fell in love with microbiology. Just hit a lot of things that I liked, from the chemistry, the biochemistry, but also the genetics. So here we're talking like the early 90s. We started to hear about cloning and making bugs do all sort of things, and I thought it was just fun to have a career like that. So I had that privilege to eventually do that kind of work. So went to Quebec to work on plant microbe interaction. Basically, was how could we use bugs to improve plant health and maybe mitigate the use of pesticides. So I was doing a lot of screening on microbes that have that kind of capacity in helping plants get more food, or protecting them from fungal attacks. So a lot of focus at that point in my career on the environmental application of microbes. So and that eventually led to a PhD in the same kind of space, and eventually a postdoc further south. So after I finished my PhD and also got married, so I did two things in Canada: not only school but also found a wife. We went to Massachusetts and did a postdoc there. So that kind of captured, let's say, my upbringing, and the start of this career in interest in leveraging or using biology as a mean for developing practical solution that I'm super happy now that we see it being applied in being commercial.
I love the thought that, I've still not really grown up. I'm still a child. And, I have daughters, and they have to tell me at times, Dad, when will you stop acting like my brother? You stop troubling us and needling us.
I do the
It's
same
like,
thing, yeah.
well, that's what comes with this packet. So, you don't have an option. Now you were born through me, and this is what you ended up with. So
Exactly.
I hear you when you say that. Um, and was there a reason that you got attracted to microbiology in the beginning, or biology maybe, and then microbiology? Was there something in you that was looking towards understanding the natural world more? Where would you put that, onus?
Yeah, yeah, absolutely. That's definitely it's always a full package, like you said. So there's that kind of interest that is, let's call it intellectual curiosity, mixed with a little bit of spirituality, kind of trying to make sense of things. And I think I just had this knack, or this maybe natural inclination of getting biology, just understanding it a little bit faster than, let's say, some mathematical concepts, or it was just kind of a natural thing for me. So basically getting that kind of feedback from my professors and mentors enforced that kind of feeling. And I think the first time that I was in a microbiology lab, I don't know, maybe the smell of it was part of it that kind of it was very interesting and intriguing that this little thing that we can't see has such an impact on a lot of things. When you look at microbiology, whether it's medical, environmental, um, many aspects where we have a different word that is out there that is extremely diverse and extremely impactful, and that we need to understand. And when we can, we could leverage it to our advantage. So, and having those tools now being developed to guide that kind of let me use the word catalysis or biocatalysis, meaning that we could take one product and turn it into something useful through this kind of processes. That was just amazing for me, just very powerful. And then again, it's an area where had that kind of natural talent, if you will, to respond to it and leverage it and communicate it as well. Because with time, it was not just about me, but also about others. And so I had the privilege also to mentor and help others to grow in this space. And I feel a lot of people connect to it, and you could definitely see it in the space where you are right now. There's this kind of connection to nature, and for me, I look at it from this biology and microbiology standpoint, and through the discussion, you will see that eventually it turned into some sort of full circle, because you see, I'm talking here kind of at the beginning of life. How can I use bugs to make things? But in the last 4 or 5 years, I'm thinking about how can I use bug to destroy things and break down things. So
Yeah.
it's kind of coming
Yeah,
into
yeah,
some
I
sort
see
of
that.
circle.
Another incident that came to my mind, it's a funny one again. I remember when I was young, maybe 18, 19 even, I had a very dear friend. It was actually a very dear friend's sister who was a microbiologist, and she was a little older than us, and she was working in this lab. And I remember visiting her, and I was really hungry somehow. And she said, "Oh, would you like a pizza?" And I said, "Yeah, sure. It's in that fridge. Just go get it." Munir, you'll understand this. I go in, I have nothing to do with biology. I go in, there's all sorts of things hanging in that fridge, the rat's lungs or whatever else, and there's a pizza right there, uncovered, just there. And I'm like, oh my gosh, I cannot eat this. Sorry. But that was the experience that I had. My first experience with a microbiology lab was getting a
Yeah,
pizza from the fridge, which had everything in it.
yeah.
So it was
No,
so funny.
that's amazing. And probably maybe I started hearing about back in those days, hearing about this company is making bugs make this kind of medication, and it was just intriguing that these bugs would have this aspect, but would become really a catalyst for even more interest. The time during my grad school, the aspect of bioremediation. So here you have a group of microorganisms that you could use to consume, let's say, oil spills, wastewater treatment. It was just, wow, this is amazing to have this power in our hands to leverage such thing to, solve big problems. So so there you go. It was kind of this combination of all these things that one of the things that it did, it kept me busy. So I'm always thinking about these things.
For sure. And I don't know if you've heard the famous Steve Jobs quote, and I think it'll take us further down when we start talking more about the packaging domain. And he said, all the future of packaging is actually going to be biology and technology, which is exactly where you are. And it's actually a Steve Jobs quote. And he talked about packaging. And he said that, this is the future. And I totally see that, because when I look around this, nature's packaging is so spectacular, and everything is packaged, and the base substrates are so simple, and the periodic table usage is so narrow, and it's just so wonderfully done. But I definitely want to pick your brains on that. But just before we dive into
Yeah, sure. Yeah.
packaging at Eastman a little bit, so you go from your postdoc to Terravite, which is more of a biology oriented company. So let's talk a little bit more about that, and then why Eastman, and so those two together
Oh,
maybe.
I love the question, and I like talking about that. So, during my postdoc year was also another amazing experience because at that time, so remember, I'm in Canada working with these bugs, engineering them to have these properties to help uh, grow plants, and I had a at that time I started focusing, meaning it's going to be an environmental application for my career. So I had this opportunity at UMass Amherst with Derek Lovely, a superstar when it comes to environmental microbiology. And what was really interesting was he was working on a group of microorganisms. And listen to this one. They were respiring metals. So when they grow, they use metals as, I don't know if I take you back to high school years, there's respiration electron transfer chain, the way that cells or mitochondria generate energy. So just like we use oxygen as the well, let's use some science here, like it's our electron acceptor. So we breathe oxygen by putting electrons coming from the carbon on oxygen. These bugs, they were using metals, so they would breathe in, so they take like iron oxide, and then they will turn it into a magnetite, so a different kind of iron too. So it was just amazing because the application of that here became extremely wide, because that process of electron transfer can do at least two things that were identified. One of them was a bioremediation applied to uranium, where you could take uranium, especially in sites that are contaminated with uranium, they get reduced to an insoluble uranium that mitigates the contamination, the spread of that. So there's a lot of support coming from the Department of Energy for that kind of research. We got also some money for microbial fuel cells. So now we have microbes making electricity, especially for like remotely located devices. So there was this new world that Lovely and his team discovered regarding a new way of communication between bacteria through electricity. So if you look up a publication about what are they called? Just some structure that transfer electrons, which is quite unique from a process, but also from the how the material is made. So there's a lot of insight there.
And sorry, I'm interjecting, but there is a lot of chemistry to electricity in nature, and we can look at the stingrays of the world, and all of that as well, right? Is that a similar domain? Of course, at a bigger level.
There you go. Yeah. So it's and yeah, and I'm sorry I could not remember the name. It's been a while, but it was a really big discovery in the field of electromicrobiology. Okay, and nanofilament or electrofilament. I forgot the specific name of that. So there was some publication in Nature and Science about that phenomenon. During that time, when I was in academia in this field, I had an opportunity to work with a company in San Diego looking at the commercial application of these technologies, and we submitted applications for the National Science Foundation through their small business award system, and we were funded for 1 year and 2 year. And during that process, I fell in love with the commercial side of science. So it was just okay. It's fun doing things in academia, and people are doing some amazing work there. But I felt more at ease and kind of mission driven when it was a commercial application for these for the science. So that's when I got the opportunity to join this startup company in Illinois, Tetravite Bioscience. I was leading their strain development group, which is making bugs that will generate more biobutanol. So unlike ethanol that is used for corn, we were looking at butanol. It's the same kind of alcohol, if you will, but a little bit bigger, with 4 carbon instead of 3. And then we grow that the business. It's still a startup environment. You remember, when you are in a startup, you're always looking for that big fund raising, or eventually a successful exit. That happened with an acquisition for Eastman. So Eastman was interested back then for the biobutanol, because we go back to 2011-10 timeframe. And it's not only for Eastman, but everybody in space of chemicals. They started looking at bio-based, or bio-based routes, I wanted to say, because the price of oil back then got to $150 a barrel, and the economics started looking favorable for biobutanol. So that's how I landed at Eastman. So for about a year, I was working remotely at Illinois, and then eventually the team was brought to Kingsport. So right now, where I live in Tennessee. So it's been 12, 13 years that I'm here. So I moved from academia, startup, to
Interesting. Yeah, it's interesting. Yeah, because I was wondering how this transition happened, and of course, so in a way, it kind of came to you rather than you going to the possibility of shifting kind of domains. But so this cues me really well, because I really want to understand Eastman and understand what the company is about, because it's been there for over 100 years now. And of course, growing up, we knew Eastman Kodak and the 35 films and the cellulosic films there.
Yeah.
So that was what was familiar. But of course, there seems to be so much that Eastman does. So can you talk to us about Eastman in general, and how it started, maybe a little bit of the history, and then of course leading to what its strong points are.
Okay, so so Eastman is one of the largest chemical companies in the world. More than 10,000 employees. We are located in multiple countries with facilities. I mean, we have offices, but also manufacturing facilities. The biggest one is here in Kingsport, where we have our headquarters. So, from a history standpoint, this is very interesting, fascinating. So it goes back to the early days of movies. So the movie industry used to actually use nitrocellulose as a film. And nitrocellulose is extremely flammable. So they had some bad fires in early days when they were using bad fires in movie theaters. I mean, imagine you have a film going and you have a light behind it, kind of warming it. And so they had some bad fires. And that's where George Eastman, developed this solution for cellulose acetate instead of nitrocellulose. So the first application was for film. I mean, it was the early days of Kodak. So if you remember those days, so where we had the normal cameras before the digital years. So that's how it started. So the X-rays and the acetate films, and probably when you were in college, you've seen professor using acetates that were used in retroprojectors. That's cellulose acetate. So what is it? I mean, it's the cellulose that has been modified to give it a number of properties from a processability standpoint, so it becomes thermally processable. So you can make what we call quote unquote plastic, although this word sometimes is a little controversial, but it's a property of the material. So you heat it, it changes shapes, you cool it, it keeps its shape. So then it's the cellulosic. Probably we are one of the first companies using biomaterial, biopolymers. Eventually that changes or evolved for a number of applications. So it's not only cellulose acetate, we have cellulose acetate propionate, butyrate, and then the application space is wide. It could be anything from plastics, like we see them, like durable, but also coating. So you could use low molecular weight material to make coating. So we have our offers in the auto industry for coating. We have some other application regarding textile. So cellulose acetate could make a fiber as well, could be spun and make a fiber. So Naya, for example, that we have right now, it's in the textile application. Controlled release that is used in medicine, so that the release of the ingredient happen in the intestine, not in the stomach. So that's also another application. And we have also optical applications. Think about the TV, like the first color TVs in the 70s. You had to always be in front of it to have a clear and sharp picture, but then with time you could see it also from a different angle. That's an Eastman technology as well. So that's the cellulosic aspect that is pretty strong here at Eastman, but we have also our polyester and copolyester applications. So Eastman used to be in the PET space, but we divested that business, but now we are mostly on the copolyester. So you have PETG, Triton. So these are durable plastic in application, especially in medical application or hydration. So now, with all of those products, we have a diversity in our portfolio. Think about our small molecules that will go in ag application. We have organic solution for the displacement of antibiotic in animal feed. Application also in construction. So interlayer films that maintain a good climate inside the house versus outside. If you have seen the new cars with the heads-up display, that interlayer technology is an Eastman technology. So a diversity of portfolio across 4 businesses, and so it's really fun. And right now, where I sit, I'm not in a business unit. I'm in corporate technology. So we are the engine for innovation at Eastman. Although innovation happens across the board here, to be a specialty company, you need to be innovator in all the different functions. So typically we start an idea here, it becomes a stage gate project that eventually, once it is validated, it moves to a business unit. And for the last 4 or 5 years, I'm working on the Aventa that is targeting the food service and food packaging space.
Yeah, that we have to definitely dive into. So, would you call Eastman a more of a material sciences company or still a chemical company?
I would go with the material company. So, and you know what our CEO always say, we are improving life in a material way. So definitely there are some chemicals there. This is the way it is, but our focus is on the material aspect. That's a good question.
Yeah,
I've never thought about it that way. I always think about it as kind of inclusive.
yeah.
Uh, Definitely, and it's beyond. Yeah. So definitely, we think about ourselves as a specialty company, and we think a lot about how to improve life in a material way, which is core the way that we think about it, and we will discuss it. There's sustainability, there's circularity. So there are some lenses that we have put deliberately to be competitive and to develop solutions that matter and that are appropriate for the macro trend that we are seeing right now.
No, yeah, that's what I would have assumed by what you were talking about, and so just a question on because the outward looking face of Eastman was a lot around these films, right? The photographic films. Was there at all a big hit because of that market dying down, or was Eastman already ready for it and they had a diversity of portfolio created by then? Do you
Well,
know the history is there?
what happened? Yeah,
Yeah.
that's a very good question, That what happened in the '90s? There was a split. So what used to be called Eastman Kodak was split into Kodak and Eastman. So right now, Eastman is an entity by itself. It does not have that kind of exposure that Kodak had. So it was a very good strategic move, given what happened to the photo industry. So yeah, we're doing just fine. And if you look at our performance, we are always close to 9 to 10 billion dollar um, business every year. So,
Yeah,
but
and
but
that's very, yeah,
yeah,
because Kodak, of course, was hit hard. So it's interesting that it was very timely, the split,
yeah,
that like Kodak took that business and they of course were significantly hit. Okay, that lines us well to the Aventa area, which you kind of
right.
inferred to. Let's talk a little more about that and how does that business unit operate? What are the focus areas? And then of course we dig deeper into that subject a little
Yeah,
more.
sure. So that was we're always innovating our portfolio, and we can talk a little bit about it because it's very important on how we are successful in this space. So what is very powerful for us is our technology platform. So we have the assets to develop the solution at scale. That is very important. So we are also very good at application development. So when we approach a market, we approach it in a very disciplined fashion. Typically, it's adjacent to where we are, so our likelihood of success is very high. High. So application development is also one of our advantages. And then we engage the market in a relentless fashion, meaning that we align with the aspiration, the expectation of the market. And in sometimes, we are leaders, we are ahead of the curve, if you will, like the example what we are doing with molecular recycling. So Aventa definitely fit in that approach. So we feel good about our capabilities to drive this business to success. So we're looking probably somewhere around 150 to 200 million dollars business for the event in this space or maybe in cellulosics in general, I would say. So so we have the cellulosic platform that is available. Basically, how does it work? We take pulp, we modify it, and then there's a plethora of application. We talked about Aventa in packaging, we make cellulose acetate, coating. We have the micro powder in cosmetic application. We have coating for paper coating. So you see, we are also looking at compostability, and we'll talk about it from a coating standpoint. And there are other applications that are growing in our cellulosic portfolio. And this is very important, Ved, because it captures two very important pieces of the puzzle that fits nicely in a circularity model. So we have this material that is bio-based, but built in it is an end of life that is sustainable. So whether the material is going to end up in a compost, and this is what we want, and there's there are a lot of work to be done there to increase the compostability of material. Probably you are in the same boat, but there's also, especially in application where there's a high likelihood of environmental leakage. So think about um, um, home care and personal care for other application of cellulosic, not necessarily Aventa. There is this possibility of environmental, end up in the environment where the inherent biodegradation is going to drive the non-persistence of this material as microplastic. So this is what we say, but in a very responsible way. I mean, but in case of environmental leakage that could happen, then these materials that are cellulosic in nature and have a built-in biodegradation property, they're not going to persist in the environment. So this is where Aventa plays, definitely in a space where convenience is extremely important in single-use application. So people need articles that they are used to and that are under risk of bans. So we see, for example, polystyrene trays, polystyrene cups, where we are developing a product that deliver on the expectation of the customer. But there's also another player upstream that is very important. That is the converter. That is the you know the the node where the material is going to be made into an article. So those are also looking for material that will be a drop-in in their operation. So we're not coming with a material that will require change or a big change in how articles are being made. So this is where the team is deliberate in elevating this value proposition, and I would submit to you across the whole value chain. So we care about each player in that value chain and creating the value for them, because that's the driver for behavior change, making sure that we are creating value across the value chain. So what I basically say, we want to make articles that behave to the way that the converter is expecting, that is creating a value for the brand, and that the consumer are going to use in a satisfaction, without compromising on their experience. So where they use a cup, it's not going to fall apart. Or so these are the area where we are pushing for Aventa right now. Focus a lot on food service.
That's wonderful. And I think that's one of the biggest challenges to solve. Just taking a step back on, so my very, very peripheral little understanding of cellulosic films or cellophanes is around the idea that, okay, you take alpha cellulose and then you take it and react it and create it into film, which probably is what you call cellulose acetate. And then use it in many, many forms. So can you elaborate a little more on how does it become a film? A cellulose is a fiber, and then and then you can purify it, but how does the process work? How does this convert to a film itself?
So I'm just going to make two differences, and there's this confusion in people's heads. So there's the cellophane, which is cellulose that has been processed in a certain way. It's dissolved and reacted with some chemicals to give it that property of being solvent cast. So it's not going to necessarily be processed from a thermal standpoint. So that's the cellophane. Now, cellulose, how we do that? So basically, we start with a pulp, like almost a paper pulp. So it's coming from, typically all our materials coming from sustainably managed forests. So we're not in a deforestation program here. So it's really commercial forest where we get that pulp and we react it with acetic acid. So there's a chemical process for adding that acetic acid, which is vinegar. So acetic acid, you add it to cellulose at a certain ratio. So it's very important. This is some of our IP and insight. We have the right ratio that gives the cellulose now this new property. So it becomes cellulose acetate. You have this many acetic acid per unit of glucose that's in the cellulose. Once it is in that stage, then you could add some processing aid that give it that kind of flow when it's heated. So in the moment you have that kind of flow, then once you cool it, you can chop it and then you have pellets. Now those pellets could be used in any kind of extrusion or thermoforming and so on and so forth. So you see there's a lot of manipulation of the material to enable it to perform to the level that it requires. In the same time, and this is why it's very important to talk about compostability and certification. So as we make these articles, we are also subjected to certification. And that certification is going to be dependent. I mean, the performance of a given formulation is going to depend, meaning that you could make a formulation that could pass the certification at a certain thickness. But if you want a higher thickness, you might need to change the formulation. This is where you see different grades that are provided for different applications. So we have one grade that we use for our foam trays. We have a different grade, which is just a different formulation that is used for cutlery. See, this is very important to talk about this aspect, because this is where we spend a lot of our time. The material is in itself biodegradable, but then to qualify for the compostability, we spend a lot of time in formulating appropriately those articles so they are certified. So right now, if you look at our portfolio, we have commercially compostable certification. So this is the BPI, for example, and the two of Austria, and we have also the home compostability certification as well. Looking at that also as a differentiating value proposition, but that built-in biodegradability is also very important. So I don't want to talk too much about the product, but go just like as you asked question, but more than happy to talk about the end of life as well.
And I love the idea of it being like a pellet. And you inferred a little bit to the converter, and that's really important because the businesses will not change their entire supply chain. So really making, I have a little bit of understanding of the Futamura technology, but as far as I know, that doesn't come as a pellet. So then it's a cellulosic film, and you nobody can blow it. So I think that has its limitations there. So I think this idea that you can create a pellet, and then does that mean that the converter has a lot of flexibility in playing with it, with temperatures and with different melt flow index and extrusion systems, etc.
Yes.
Does that give a lot more flexibility then?
Absolutely. So exact. So then you will see a lot of similarity in our properties to those of polystyrene or PET. So customers typically have minor changes. Or I mean, it's a new product, it's a different product, but it's not. It's going to run in the same kind of asset that is used, let's say, for injection molding. Obviously, you have to adjust the parameters, and that's something totally normal. I mean, if you change one polypropylene supplier to another one, you got to change the parameters. But yes, so we sell a pellet in the market. But typically, and this is my role when I work with customers. Now it depends. So I provide guidance. What are the thicknesses? What are the parameters to make sure that customer is going to qualify for the certification? Because most of our customers are looking into a compostability certification, and those where you can't make any product you want. I mean, fundamentally you can make anything you want, but you will be limited. So I don't want a customer to make a phone case with our material expecting that they're going to get a certification. They can make it if they want to, then they're totally fine doing that. But I provide that guidance that, hey, this is for food contact or for food service. So if you want the certification.
I found your idea, you inferred to it a couple of times on the foaming side, and I found that to be fascinating because I just feel when you look at a styrene kind of foam,
Mhm.
it's actually so flexible in many ways. And it also, if I've always dreamt of this, as a structure, if you look at a styrene coffee cup, then there's a natural insulation property. You don't have to have like that triple deck sleeve, and the some barriers are probably built in, so you don't have the challenge of another coating. And I've always thought, if somebody can crack this code in a more natural substance, then that'll be amazing. And
Yeah.
you kind of inferred to the product integrity as well. So I would love to hear more about, the idea of the cellulose diacetate foam, and then how you guys are looking at, can you foam it the same way in a similar polystyrene kind of machine? You inferred a little bit to the product integrity and keeping the shape, and then the barriers, because that's the other thing. If there is a liquid that is going to go in, does the,
Right.
the material itself create a barrier, or how do you manage that within the conversion process?
So yeah, so as far as making the foam, yes, we are able to foam, and our customers are able to foam our material. And our foam, Aventa foam, is in the market right now. So it's used as in protein trays. So this is, as you can imagine, a huge opportunity for us. Our foam trays are certified home and industrially compostable. They deliver on the functionality. They don't need any kind of grease barrier because the materials in itself does not have the. I mean, it looks like foam. I mean, it's just like a polystyrene foam when you look at it. When I work with composters doing some testing, they say, "Hey, don't bring polystyrene to our facility," and I'm like, "Well," and this is a challenge for us. I mean, we need as a company, but also as a a player in enabling more composting to be sensitive to composters' ask. So color is going to be very important. So we are working to make a color that composter will feel at ease with, that they think that they're getting polystyrene trays. So we are able to achieve that. So it's our customers are super excited about it because they run in the same operation as a foaming line. So we formulated in a way that it's formable. We have really low densities. I think the lowest we have now is 0.05 or 0.06. Pretty thick and still maintaining the compostability. So yes, there is a pretty good value there for the protein trays, whether it's chicken or meat, beef meat or sausages. So there's a lot of interest there, and as I said, there is already some commercial success there.
And are you looking at deeper products like a cup?
So probably this is what we call our multi-generational technical program. So we need wins right now, focus, get the protein tray, and then eventually move to those deeper application for the cups. So yes, in the future, I don't see why the team is not going to be able to do that, but definitely it's something that we're thinking about. Right now, it's getting the protein tray out and done, and we look at that. And there are a lot of applications. I mean, I think anything that touches food should be compostable. And when you look at nature for inspiration, I mean, everything that, any packaging for natural packaging for food in nature is compostable. So orange peel, banana peel, you name it, everything has to be compostable. And it's not only us. I mean, there's a lot of brands that are thinking about this. And it's very challenging. I mean, it's not easy to come up with these solutions, especially when you look at the flexible space. These are highly engineered solution that we take for granted as consumers. You buy your Snicker bar and you just cut it and have your chocolate, but how that packaging is made and the speed is amazing, what it delivers in functionality. So there's a lot of opportunity for innovation in this space, and I feel like all the brands are aware of this situation, that there are some material and product that are not recyclable, and composting could be one way to achieve that kind of circularity.
And personally, I always find recycling a misnomer if it doesn't have an out in the end. So you can downcycle it to a certain extent, and I'm not even considering the chemicals that go within the creation of the product. But in the end, there has to be an out of that chain, right? So yeah, so a cellulosic product will always have an out. So yeah, so if even if you downcycle it at some point, even if it's thrown, it is going to go back to nature. But if you look at a petroleum-based polymer, typically, it'll become polyester end of the day. And then what happens? After that, there is no going back. Or even it's a polyethylene, it becomes this loose, black colored. They put in black color and everything gets hidden. And then after that, what? So there's
Right.
always that challenge of downcycling.
I like that. Yeah, I like that, Ved. And let me talk a little bit about that in Eastman perspective around molecular recycling. So, and this is addressing the issue that you just raised. There are some products that inevitably are going to end up in landfill because they don't qualify for recycling. So we call them hard to recycle. And this is where molecular recycling is a paradigm shift, if you will, on how we think about recycling. So I always think about recycling in two ways. The first one, it's technically amenable to breaking down, right? And you can rebuild something with it. So that's one part. And the other one is a business. So you're making something that's commercially viable. If you just recycle for recycling, it's not going to be sustainable. So what we thought of, the way that society always thought about recycling was, I'm going to start with a PET bottle, I'm going to chop it, and I'm going to melt it, and I'm going to make resin and then make another PET. Like you said, there's a molecular weight decay and so on and so forth. But there are other products that eventually will all become black or just dark color when you recycle them. So molecular recycling come with this aspect of, I'm going to take all these hard to recycle product, I'm going to break them down to a carbon component, right? Just like I would do with the Lego pieces. And then I'm going to build whatever I want with it. So we have two technologies here. We have the polymer recycling technology, which is basically taking a diversity of product and breaking them down to the carbon level. And we have the methanolysis, where we take PET, especially, there's a lot of PET in the world that does not get recycled. One of them is carpet, for example, that they don't get recycled. They end up in a landfill. We take that product, we break it down to its monomers. In this case, we have the DMT, the dimethyl terephthalate, and the ethylene glycol. And then we rebuild because we have now the starting material. So you see this paradigm shift of going from a material that is chopped to always making the same thing. You have now the flexibility of creating a new recycled content that could be put in different products. And this is a big investment for Eastman. We are way ahead of any company there in the world. And we could leverage those kind of content in a diversity of portfolio. So I can have a cellulosic material that has a renewed or something that would have gone to the landfill. Now I built it inside a product respecting the molecular composition, and it's maintaining its compostability and biodegradability. So I could have, this is the beauty of it, I have a bio-based content, but I have also remediation to a problem. So this is create like a really cool sustainability story, and this is the evolved circularity, if you will. Now it's not just a matter of taking material, capturing it, but solving a problem. So taking that kind of accountability of or commitment, I would say, for fixing a problem that already exists. I think this is an amazing opportunity for Eastman and for the industry to start thinking about this remediation aspect.
So what happens to the additives? Because typically, especially in any kind of polymer kind of chain, there's so many additives that we end up adding. There's also the inks and et cetera, et cetera, et cetera. So
Yes.
even if we avoid that part, there's still a lot of additives. And the second part, like at one point there was so much talk of what was it? It was forgetting the word, but basically they were taking it to that temperature where they were converting it to fuel, pyrolysis. So they were doing pyrolyzing it. So that was another technology, and there
Yeah.
became this hype. But the challenge was again, the quantum of energy use was so high that it didn't make sense. So what happens here? Number one, with the amount of additives and additions, and what about the process itself? Is it amenable from a perspective of energy and yield that it'll make sense?
Absolutely. Yeah. So I think it comes down to, well, let me ask the question. You have two questions there. So for in terms of additives, so as you're doing this process of creating a new starting material, you are cleaning, you are removing those impurities. And this is the challenge for us. I mean, the challenge that the team has overcome here in Kingsport. So yes, I mean, when you're dealing with waste, dealing with a diversity of product, and we always strive as a society in the last maybe 20 or 30 years to use waste as a feedstock. But it's extremely complex because of the contamination level. So when you're running this kind of process, yes, you will remove the contaminant because you want to end up with a product that is acceptable by the customer, so that there's no question about it. I mean, imagine for food contact, you're not allowed to have any kind of ingredient there, or human contact. So that aspect is definitely addressed in our process of removing that. Now, when it comes to the manufacturing of it, yes, there is an energy associated with it, but when we do the LCA analysis, it's still good. It's still going in the right direction. So it's very easy to say no and not try things. So we are doing it, and when you do the math on how the LCA of this product look versus a virgin source or virgin another recycled product, we are always advantaged. So this is where we find the pull coming from the customers, because now we have some regulation and legislation that are asking for recycled content. which is a good choice. I mean, kind of pushing the industry to come up with solutions that are sustainable in the long run. We can't always rely on virgin sources. They are, for all the reason that people know. I don't think I need to preach on that aspect. So right now there's also that regulatory pool that exists for us, but still, there's still a lot of work to be done there. I mean, we're not there in terms of uh, the challenges that still exist. This is a change in behavior, but we are seeing success happening, and we will continue in that journey.
And it's good to hear that early on you're looking at the LCAs because that'll give us a good indication on, whether it's in the right direction. And I totally agree with you. It's very easy to be a naysayer, right?
Yeah,
You know, but
yeah,
but but if you don't try, you don't know, like and
absolutely.
as we grow in experience and in age, we get more blinkers on. And it's always good to have young energy than to poke holes, like, nope, cannot be done. So, so that's the challenge because you
Yes,
never know when it
and
can be
it's
done. So
something that I tell to junior scientists. It's always a huge opportunity when somebody tells you it can't be done. Because if somebody tells you, yeah, we can do it, there's no value there. So I always tell them, yeah, the moment you hear pushback, somebody telling you, nah, you're wasting your time, it's impossible, that's a huge opportunity for innovation. And I'm happy that, as an organization, we encourage this kind of behavior of taking challenging things that really are worth our time.
it's amazing because I was just again thinking of this. There's this book I was reading, Never Split the Difference, and it was interesting that they said actually negotiations start when there is a no. Because if there is no no, and many times I find people say, "Oh, he said no, so it's done." No, 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 no. That's when negotiation actually
Yes.
starts. There's not a hard no. A hard no can be a very different thing, but even it goes to the extent of saying even if it's a hard no, there is always a methodology that there is always a conversation to be had. So you're so right. Just taking a step back and because there is some important things that you guys are doing, especially on the foam side. We've tied up with Sealed Air, for example, and that's a
Yeah.
huge company. And so tell us more about that idea. And is that to propagate further? And how does that collaboration work? And how is that going to lead to a mutual advantage and growth?
Yeah, exactly. So definitely a solution that we are developing has to resonate with our partners. So the example of sealed air is one of them. So everybody knows that polystyrene is under a lot of scrutiny. I mean, it's banned in some places. There's still some applications that are allowed, but for the most part, the writing is on the wall that polystyrene is going to be banned. So you have companies that are on the forefront. They are thought leaders, and they see the move happening, and they make a move as soon as possible. So Sealed Air is a great partner that they're learning from us. We're learning from them, and made a product that fits to their expectations. So we see Sealed Air also activating their downstream chain. I mean, they are a node in the whole value chain, and elevating all the values that we are creating for that for that space. So there's a lot of protein trays that are being used right now. The majority or the totality of them is going to end up in landfill. So this is an opportunity, especially. I mean, you could play the game of identifying different kind of customers downstream. So you have those that have sustainability in their DNA. So they're always talking. They're perceived as a sustainable company, and those are the ones that you will find that they are definitely looking for a solution like that. And you have others that are pushed because of legislation. So there are some legislation that market access for them has to pass through either recyclability or compostability. So the problem with the protein trays is that when you put PET, it does not deliver on the functionality that polystyrene like material has been doing. I don't know if you could take a box of PET trays, and you see the difference of weight with one that is foamed. So there's the cost of transportation. I mean, there's all these things that are not necessarily intuitive that are built in this case. So that's what I could say about Sealed Air. I really like the partnership, a great team that they have there, and So it's allowing us to validate our solution in the market. And
No, that's wonderful. I think it's because the world is always going to be about this cohabitation and collaboration. And the more we open ourselves, the more cross learning there is. I also wanted to ask you about because I hear a lot of effort also on the molded fiber side for similar application. How do you see it in comparison? And it could be both comparison in terms of performance, in terms of cost, and et cetera, et cetera. How do you see that as a substrate?
yes, I think there's innovation across the board. This is a very dynamic space, and yes, there are some products there that I've seen that are very good. There are others that still need improvement, and it does not mean that they're going to fail. They're going to succeed. Um, I think it's the way that I see it, that when you talk about molded fiber, there's always a need for some sort of additive. So to provide that functionality. I mean, it's very hard to deliver on a number of things, Uh, I mean, grease protection, what is it, permeability and whatnot. So I think there is a play there. So, for example, we have a solution here called Solus. So it's not Aventa, it's Solus, but it's for paper coating. And in that case, we are developing a solution that help those paper coaters, those mills, to run at the speed that they are used to with the PE and still maintain all those certification. So, so you see, we have a solution that could be considered maybe competing for paper-based product, but we have also another solution that would enable uh, paper-based product through our Solus, which is also another cellulosic. So I think at the end, there is the material side that we focus a lot on, and that's fine, but that's good. But there's the infrastructure aspect that enable all that innovation. So we could spend a lot of time and money developing all these solution, but what I'm spending a lot of time right now is making sure that we create a system that is going to enable this material to really end up in composting or anaerobic digester or any ways that really that aspiration is going to turn into reality. So I'm supportive for all the solution. I think we need recycling, we need composting, we need multiple kind of material. We just have to fix the waste problem. What we are doing right now as a civilization, I would say, I mean across the board, has to be addressed. And one of the way to do that is through the infrastructure, which has education as a piece, the infrastructure itself, and the regulatory framework to enable that to happen. So that's a place that I think is worth for us to spend a lot of time. I mean, sometimes it's not transactional as the one that you have with a business operation. So it's an area where we need a lot of collaboration, and we can talk about that because there's some really interesting initiatives that are happening right now that need more and more support.
Yeah, and I will get to that because you play a big role with BPI and being part of that board as well. But I wanted to talk a little more on something again you talked about a little bit on the flexible film side,
Yes,
and of course that's a huge challenge, especially a multi-layered flexible film that needs a WVTR and OTR of under one,
yes,
and that kind of shelf life and it's a huge challenge, and I'm sure you guys are thinking about this. So, how do you see that play? And then typically, you've seen cellulosic films work very well with oxygen barriers, but the water vapor barrier still remains a challenge. So, do you
indeed.
see the future where the Lay's potato chips and the Mars bars will be wrapped in something that's compostable and yet, are able to have the performance that they need because you don't want the food inside to get bad, and they won't
Exactly.
agree to that anyway. So
Yeah.
so yeah, how do you see that part?
So I think it's happening, and I'm close to some of the leaders in those companies. I'm not going to name names that are in the snack and for those flexible, and they are definitely committed to compostable. There's no way that they're going to leave that. I mean, I can feel and I know that there is a serious commitment from their leadership, from their designer, from the whole corporation is committed to compostable material, and they are fixing the problem. I mean, I've seen prototypes; they're getting there with like a multi-layered compostable solution. So it is happening. I think it's going to take take time. Right now, it's not in my portfolio to look at it, but we would definitely, with time, be involved there as well. So it's just, I mean, I'm very happy about it because I know those people are in it for the in the long run. So and looking at those prototypes, they're getting there. But then again, it's not just a matter of making a prototype. It's having a regional or maybe a country level distribution with those kind of product. And then that product, you want it to be captured and then end up in the composting pile. So there's a lot of play right there. So imagine, how are you going to differentiate it from a labeling standpoint? I mean, you're used to look at that chocolate bar in a certain way, but now you want to message that it's compostable. And there's a lot of brand equity there that has to be addressed. And yeah, it's just exciting because this is a paradigm shift on the way that we are thinking of the product that we are putting in the market. You've heard about this EPR, this Extended Producer Responsibility Scheme, which which is very important to eventually help all these products end up the way that we want them to end up, recycled or composted. So I think the interplay and the collaboration across all these stakeholders is going to get us to a place where it's not just a material solution, but also an infrastructure and end of life, um, you know, uh, kind of enablement of that material, if that makes sense.
Yeah, and it's again same like earlier what we were talking about in terms of pellets as well. It's a whole supply chain that's built. There are huge machines for conversion, if not trillions, and definitely billions of dollars invested in the Amcors and the Pactives and the Novolexes of the world, which are converting films, and you cannot make that defunct either. So it has to be able to run on those machines and perform at the same or similar level, so that they are ready to take that material as well. So it is more nuanced, like everything else is. Like there's the consumer side and the customer side and the converter side, and then there is the base material. So at least those chains need to be adapted to the current structure to be able to make a quicker shift. Otherwise, if you come up with a totally new conversion system, it will take a little more time to be able to adapt. So yeah, so I see your point, and it's very nuanced. So the other one, which is really interesting, is the big investment that you guys have been part of from the Department of Energy, and I believe that it's a 375 million investment on decarbonization. And tell us a little more about that, and how that works.
So yeah, I mean, it's expanding our methanolysis effort. So having another plant, and this one is gonna be in Texas, and yeah, and there is this support that we're getting for the Department of Energy. So it's a big chunk of money, but Eastman is investing also a lot of that money. So yeah, so it's in the same mindset. As I told you, there's a lot of waste out there, especially the PET waste that is going to the landfill, and there's a commitment, and it's great to see this kind of support that we are seeing from the government. Um, to help us grow, and because it's a complex story. There's the technology, or let's say the conversion side, but there's also the waste collection side, the waste qualification side, and then you have to qualify for the customer side. I mean, for the commercial side. So that's very exciting that we have this kind of validation for our strategy, and then getting this kind of support definitely create a lot of credibility for what we want to do with our business.
So the other thing which I hear in the cellulosic space is the whole cost aspect. Do you see that as a challenge, or do you think with scale there is going to be a better management, or I would not even call it cost. It's the value creation, right? If you
Yeah.
can create the value, cost is always in comparison. So how do you see that? And again, my limited knowledge is coming from the cellulosic films available in the market. Many times they work really well, they look really good, but when it comes to the cost, the delta is so high that in comparison, people want to adopt a PBS, or something else which is a little bit, it's still compostable, or a PLA, which is industrially compostable. And doesn't go for a cellulosic film. So how are you guys tackling that part? Because there is the base fiber cost in the end that has to be taken into consideration.
Right. Yeah. So we remain. I mean, we enter in this space, and as I told you, we are successful. So you can't price yourself out in the market. So you have to play in that space. And like you said, it's an addition of multiple variables. I mean, you can look at the material itself, how much it costs. You could also look at it, how much it costs to process it, versus another material that you can buy cheaper, but then it's going to cost you a lot to run. It's it's a convoluted, I mean, not convoluted, but complex picture. But we are deliberate where we are engaging, because we need to be competitive. That's just the way it is. So that's, I mean, that just makes a lot of business sense not to price yourself out. So definitely, as you see us in this market, and you see our success, it means that we are competitive from a pricing standpoint. And that's an argument that we have heard a lot, not necessarily targeting cellulosic specifically, but any new material that comes in the market. Let's say even the compostable material, because yes, you compare compostable material that are new in the market versus an industry that has been here for many years. So definitely there is the economy of scale that impact that. But the reality of it, somebody that has polystyrene and polystyrene is cheap, well, in the next couple of years, they can't even sell it. Even if it's cheap to buy, they can't make article of it. So the market access create a whole different dynamic there. So, but in general, we are competitive.
That's wonderful to hear. Let's take a pivot on the BPI side of Munir.
Yes.
Like the board member at BPI, of course, influencing policy regulation. Tell us more about that role and how it feeds into what you're doing overall. I think even as a human being, because obviously you're devoting a certain amount of time to that idea, and how does that drive you?
Yes. Great question. I'm happy to talk about BPI. I think BPI was a very good idea for compostable material. And to the leadership of Rhodes and other board members, but also the members in general that participate in multiple committees. So BPI is not only a certification organization, so that provides you with that label, that differentiates you, that validate the value proposition. It creates a level playing field. So everybody is playing by the rules, meaning that you meet a standard, that you have tested your material in an external, independent lab. There's a process for getting that qualification. Well, so be it. So now we have that certification logo. But it's more than that. So, and this is the opportunity and challenge for BPI as well. So there's the certification, but this organization take on the responsibility. And this was a decision like that was made by BPI to be the voice of compostable material. I could tell you there are other organizations out there that they give you a certificate and that's it. They're not doing anything else. And it costs a lot of money. BPI is different. It will talk to legislators. It's going to talk with NGOs. It's going to have position statement. It's going, it has a lobbying arm. It has a lot of effort for helping compostable material in a responsible way. So what we say, we want no more organic waste. That's the vision of BPI. So how could we enable that? So I'm really happy and excited to work with BPI and protecting EPI and helping it to grow, and work with other organizations. There are others that are helping and that are part of the journey, and just making the whole story of bioplastic and compostable material strong. This is key. So it's been now 3 years. I'm actually up for re-election, and I hope I get re-elected at BPI by the end of the year. So I need to go into a campaign mode. But seriously, very important that we have those committees. So we have a technical committee that is tracking the evolution of certification. So there's work now for having BPI home compostable certification. And this is something that we're taking very seriously. So we don't just decide one day, hey, boom, you got a logo, and then we need to understand, is it creating value? What are the chances of confusion? Would this kind of fire back on us? How could we protect the credibility of this logo and so on and so forth? Supporting composters as well. They are a very important player in the value chain. And unfortunately, I think the industry took them for granted for the longest time. And now it's time for us to work more closely with composters. So in addition to BPI, there's also the CMA, the Compost Manufacturing Alliance, that is also a good organization with the mindset of helping the growth of compostable material. And the US Composting Council is also another organization that I find a good place for us to engage with those players. So you see how I'm very passionate about BPI, because it's taking the science of composting and biodegradation, packaging it in a way that it creates a business opportunity and a market access, but also take on the responsibility to speak about it with regulators and help regulators in their program. I mean, BPI was actually the force behind the PFAS ban. BPI was the first to say no more PFAS, and BPI took a pretty solid financial hit when a number of companies were removed from its listing because of that. BPI also asked, we want all the compostable material to carry a label. And that cost a lot of money for companies to have that label. And unfortunately, some companies decided to leave BPI because of that logo. So I'm just impressive by what that organization is doing and continue to be doing with all the challenges that we are facing. I mean, there are a number of things, but I think they're doing a good job. The engagement with NGOs and becoming a thought leader is very important. So the work with closed loop partners is amazing, as having a BPI as a consultant. The INC5, the work that BPI did with USDA and the State Department in having a symposium about bioplastic and putting it as a solution for the negotiation about plastics. So this is great. So I'm grateful, and I appreciate this opportunity of working with BPI. And I think this year we will hear some really great development from BPI as we are moving to the next stage.
And yeah, just so that you know, when I started the podcast, I think Rhodes was in the first 10 people I think spoke to. It was pretty early on, and and again, Rhodes well, and it is such an open, honest conversation, and we talked all about PFAS and all the things and the reality and then the public side and all of that, and he was extremely open. And of course, we've also continued to engage with BPI, and you're right, it's definitely an organization that wants to make a difference. So kudos to guys like you who are involved and are really honestly driving that change. So just with that idea, if we look at challenges, of course there are many, but how do you see, what are the top challenges you see as an industry and as a company? What would those be, for you?
Uh, let's talk about the industry. So the industry needs alignment, and we need to talk basically the same language. I still see a little bit of disconnect, and let me break that down a little bit, if you will. So everybody talks from their own position, meaning that's what's in it for me. So it's like, well, this is how I see the world from a resin manufacturer. I want to sell more resin. Then you have a distributor with its own problem, brand, and whatnot. I think we need an alignment and maybe I'm still thinking maybe we need a new association organization for compostable material that will have that kind of trade association mindset, kind of having all the stakeholders, across the board, from resin manufacturers to legislators, regulators, waste managers, city waste managers, and so on and so forth. So I think, and we are doing some interesting development. I don't know if you've heard about the Future Search Initiative. We had a 3-day workshop, and we had a representation across the whole value chain, probably 130 or so of participants for that workshop in Denver. The Future Search Initiative is a system level kind of strategic planning where you bring all the stakeholders and then you decide together what are the most important initiatives. Typically, you try to end up with 10. It's a really great exercise because now you have, and what was interesting, we had people that were for compostable and those that were anti-compostable material. And during the whole process, you get to a phase where you talk about the goods and the sorries. And it was a really amazing exercise because that's where everybody become vulnerable and they're open. They say, well, yeah, I messed up here, but I did well here. And then create that kind of level playing field where you start thinking as a community, what does a good solution look like? And then you have the buy-in from everybody. So we did that, and Future Search is live and on. So for the people that listen to this podcast, please join us. We want to have representation across the board, and there are some very important initiatives there, ranging from how should an EPR look like, what is a communication, what is a proper label. I don't know if I said the word label. Labeling is very important. So there's 10 initiatives that are out there. So that's very important for the industry to grow. So and I don't know if this is something that will end up becoming a new trade association or eventually is going to end up in a given maybe as a subset, as a an effort inside a different organization. So that's what I think the industry is looking at. I think we need to focus as an industry with the waste management aspect. The disconnect here, Ved, that I want to submit to you, and when we talk with composters, we need to understand their business model. So, a composter is not necessarily a waste manager. Composter at its core is a product manufacturer, and we need to be aware of that. So is there a need for a new kind of composting where the composter is a waste manager, or should we help them modify their business model so they are more amenable to compostable material? So this is, I think, the challenge where things get a little bit convoluted, and probably this is something that we need to work with city waste managers and regulators to identify that. Are we working for the composters to make sure that their business model function, or are we working for the constituent to provide them with sustainable solution for their waste management practice? How could we bridge that gap? So this is where I think some work has to be done there. From a company standpoint, I think it's just increasing our output and creating good product, continue engaging with the market, validating our solution for all the product that we are putting here in the market, meaning the straws, the cutlery, and the protein trays. I think it's going to be a great 2025 for this platform, and we start thinking about what's next. Specifically for the cellulose acetate. So there are all those applications that we put kind of the back burner for the team to focus on winning this first one to validate our value proposition. And I think 2024 was definitely a validation year for us with the adoptions that we have seen for solutions that were thought to be very complex, like the foam. That's just an amazing validation for our strategy. So yes, and I'm looking forward for the next series of products that like you said, there are so many out there. Increasing the draw ratio to get deeper applications, increasing the application probably for thin films for blow molding. That will be something amazing. Although it sounds like fundamentally hard, I think the team can figure it out. So. So I'm calling out to all the, the smart polymer scientists. Come join us.
Superb. Yeah, we definitely need people to come together in both sides. And I remember Ian Jacobson from Eco Products and I were talking, and exactly the same thing. We were thinking, we need an association where there is exactly what you said, different people interested in composting and compostability, because there is a rub. And, even when we look at association, there could be the Sustainable Packaging Coalition. It becomes too confusing if you're diluting composting with recycling, and then the big money is coming from people who don't want to talk about composting. Then it becomes a challenge. So you need to have a forum where there's the multi-level people at different ends of the chain coming together and focusing, and it has to have enough traction to be able to make a difference, because that's what, a government, a regulatory body would listen to. So, so if you bring in people, exactly what you said, it's the creators of base material, and the producers, and ultimately the disseminators, the marketers, all of the people coming together, and the inventors in one whole body. So, more power to you guys if we can do the either through future research initiatives or any other, if somebody can take that mantle, and then, maybe through this conversation that we are having, hopefully somebody is thinking of this, and then we can kind of get them to take this mantle, and we can all join in. It'll be
Yes.
amazing.
Absolutely. And just to specify that, so for the future search, which is the process, but the title of it is Improving the Circularity of Composting and Compostable. So this is the aspiration. It's always like this. We have a product, a material. It's just, you know, I always give this example. It's like electric car or planes. You create the product in the beginning, but then the infrastructure comes after. So you build the plane, then you're going to build airports. You build an electric car, then you have charging station, and so on and so forth. So, and this is, I think, the challenge for the industry, where there are compostable material, but not enough composting facilities. Well, we need to work
Yeah.
a little bit more on that
It's
aspect.
not. It's You're saying it's not a chicken and egg story. There is
Yes.
something that has to come, and then something is get. But and I heard
Yeah.
enough about the program that there was a lot of rub on day one with the composters and creators, and then
Mhm.
by day two, everybody was like exactly what you said. Everybody came together, and
Yes.
we were talking
Okay.
more openly. So that's what you need. Like, come, let's have a conversation. Let's understand exactly what you said. The composter is actually a producer, let's understand their challenges, and then we can co-design the right process for humanity. It's not we're doing beyond just a business. So I think that's really important. And I'll let you add whatever you were going to say something. But the other one which I want to look at, and it's a total side note, and I was
That's fine.
pulling your leg a little bit on it before, that you're such a patent machine. I couldn't even go through all your patents. But what was fascinating for me as a microbiologist, there was so much there on cellulose and process and products, which was fascinating for me because I come from a pulp and paper background,
Yes.
and then there was so much of that there as well. There was things on molded fiber, and so that was
Yeah.
fascinating. So tell us a little more about that side of you as well. Just so that we are illuminated on how that works for
Yeah.
you.
Well, first of all those patents are a team patent. That's not Munir patent. I mean, I'm part of very talented teams that are actually the patent machines. So you see, for example, what we have done on the cellulosic side is just kind of cover a number of applications to protect our business. So that was a deliberate effort to, cast a wide web on the application where we would qualify our material and then protect it. So, and this is a strategy that all companies do, that you need to patent, because that's how you create value, and this is how you create, a security of market access. So yeah, that's what I could say. I mean, you just looked at all the applications that are out there that we qualified, but you see built in all those applications, there's the element of compostability and biodegradability. So yeah, it's always a teamwork, and we have great patent support here at Eastman, and but at the end, it's always the idea. So we engage ourselves, we challenge ourselves as a team to to protect our inventions. So patent is one way to do that, and yeah, that's business as usual, I would say.
No, but again, just I totally agree with you. It's a team effort for sure, but it's also the range of experiments that are going on, which is fascinating.
That's and I think this is, we talk a lot about diversity of thoughts that you need in a high performing team. So you need different perspective. So this is what's amazing about our company is, we have microbiologists, chemical engineer, chemist, polymer scientists, and so on and so forth. And I think that's the beauty of the work that we are doing. And probably you are faced with the same thing, that it's I always tell people it's about the others. This is the opportunity that we have. We get, that feedback. It's not about me. It's about how, others are winning and gaining from this kind of opportunities. So so there you go. I mean, it's just it does not exist everywhere. I mean, I understand there are some companies that don't have the kind of resources that we have. So we have this opportunity in this kind of philosophy on how we are approaching innovation. And you can't do it just with one hat. You need a combination of different perspectives. So yeah.
Yeah, I couldn't agree more. My a lot of my fascination, and again, you talked about this a little bit, has been with nature and the
Yeah.
packaging that you see around us. In fact, part of my master's was biomimicry. So I was always looking at I was looking at water spiders. How do they
Yes.
use amino
Okay.
acids to build their web under the water, and how does diffusion take place there, and all of that. It's just fascinating. I typically have a picture of pomegranates around me because I just think, just look at those fruit, the films in between, protecting those
I'm the
those
same as
beautiful,
well.
delicate seeds, and the building blocks of just carbohydrates and amino acids, and then
Mm.
it's just fascinating, and I think that whole idea, that whole domain, and how can we adapt and learn from that? Just the trees, the carbon sequestration. You take carbon from the air and sun as the source, and water from below, and you create cellulose, and then we take the cellulose and we grind it up, and it's
Yeah.
abstractive. So it's just fascinating. So I would love to hear just a little bit, and I'm very of the time now. So, but give
Yeah.
us a little bit on how you think about this whole idea of nature and taking it into industry.
Absolutely. I think that's the inspiration, right? It's not as clear as that, but I mean, fundamentally, you see, in the beginning, it was more like, well, how could I leverage, this the nature or biology? I call biology nature. I mean, when you're doing biology in a fermenter, it's not necessarily biology nature, but you're leveraging that. So but then what is really fascinating about nature, it is circularity. How, I mean, when you break it down, it's basically the energy coming from the sun, and you have all those carbon to carbon linkage being made, and so I like the circularity aspect of things. So I look at it always that way. So for me, it has been very easy because now the team think in this term. So we always think in beginning of life, end of life. And we have a team also looking at the manufacturing and so on and so forth. But always these two aspects are now going to play hand in hand for any kind of new innovation globally. It's not just making a product and putting it in the market, but have a built-in story. It's not only a story. I mean, it has to become in reality the end of life of it, how it's going to be closing the loop again. So, and it's one thing when you were saying this, I remember this picture that I saw myself. It was a peeled orange inside a plastic container. Who came with this idea? So there you go. I mean, we got to speak up also to the brands and tell them as consumer, hey, this thing is weird.
No, it's crazy, and yeah, there are countries where we see that happen a lot, and it's just amazing for me. And these are countries which are still aware, but like still, like if you look at the amount of packaging in Japan, it's nuts. Everything is kind of strawberries are in a plastic in a pouch, and then something else, and then something else. The other thing before we kind of take it towards closure, I wanted to pick your brains on is EU is typically on the forefront of regulation. And what we see is very fascinating aspects there. And they talk about the basic molecular structure, right? So they would consider whether it's a PLA or a PHA, it's still a non-natural polymer, whereas a cellulose is a natural polymer.
Yeah.
So can you illuminate me on that if you have an understanding of that idea, and how do you think about that regulation?
Yeah, it's very interesting how I don't know. It's one of those definitions that you don't know what's the science behind it. Is it a political agenda? I mean, there's a lot of things there. So And I don't want us to be kind of limited to those definitions, but they have implication, right? I mean, once they decide that this material is plastic, then eventually you lose market access and then to something else. And this is where we get into the situation of regrettable regrettable replacement or substitution, regrettable substitution. I mean, you end up with going back, to worse things. So for me, I always think about, wearing the hat of Eastman. It's cellulosic, so it's a natural product. It has its properties. So, what is the problem? So then let's talk about the problem that you consider exists. But having those definitions like that, I don't think they're helping much. They are basically just creating a barrier that is not necessarily solving the problem. So it's one of those situations that I'm curious how these things are going to evolve, because what will be the replacement? What are the cost of those replacement, and what is the sustainability profile of those replacements? I think the solution that were put in the market right now, they were well thought across the board here by the biopolymer that are available in the market. How could we enable them instead of just creating these barriers that I don't think fundamentally have any reason to exist? So yeah, I don't know if that helps, but that's my
No,
perspective.
no, it does,
It
and
always
I
leaves me
understand.
scratching my head on this
Yeah.
definitions. It's yeah,
I also find it to be fascinating on why the regulators sometimes make it so complex. Why not keep it simple? If it degrades, if it goes down, if it's compost, it's okay. You don't have to get into the polymer chain of it and make it more complex. But
right.
yeah, but I thought maybe you might go the
Comfortable.
other way and say that no, no, that's okay. Complexity is okay. So I was intrigued when you said, yeah, no, keep it simple. So that's better.
Yeah.
Great. Let's take this towards the closure. And my final two questions are always similar, and I'd all love to hear the answers around that. When you look at, we all know that the impact that will happen in the future has to be closely linked to scale. And you talked about this a little bit. So, how do you see Eastman looking at it? Is there a 5 year horizon where you would want X amount of tons to come out of the Eastman, company? Or there is a certain revenue that you kind of target that, okay, we have to hit this, and that also translates to a certain amount of impact. What would that dream be in, say, maybe a 5 year horizon?
You mean for cellulosics or in general?
In whichever way you want. Like you may go beyond cellulosics as well. So how
Yeah.
do you see it for Eastman itself?
Well, I mean, in general, so we are a growth focused company. So our portfolio for growth is focused on those two areas. Um, I mean, there are many products, but at its core, it's our circular economy. So whether it's molecular recycling or our cellulosic, we're driving everything with that mindset. So I don't remember the number specifically, but for the cellulosics in general, we were thinking about $200 million generated by 2029, something along those lines. So then again, check your number before you make any kind of investments. just kind of, but it's a serious commitment to that business. So we have now the facility here in Kingsport for molecular recycling growing up, and with the goal, if I'm not mistaken, of 500 million pound of plastic being recycled. So that's scale. It's big, and we have a path for that. And then we have also the facility in Texas that is also slated to start construction in maybe next year or so. So yes, so there is commitment in this space. That's something that our executive team has made us clear. Circularity is a way that we are looking at solving this major problem. I'm just going to repeat them. The first one was the plastic pollution, so we want to address that. Climate change is very important for that, and also so there's the circularity aspect. There's the climate, but there's also helping a growing population. So we have applications that are specifically addressing, the health and well-being of the population as well.
Superb. No, that's very well rounded, and that takes me to my final question. What does good garbage mean to you?
Yes. So, so I was thinking about it this morning. Good and garbage. These are two words that kind of they are against each other. But I understand the concept because I think that question begs to the issue that we have, which is garbage, and the way that we have thought about as educated people has always been, hey, I'm gonna put this trash in the bin, and I did a good thing. Everything is fine. And it's more complex than that because the majority of the time it ends up in a landfill. Okay, so that's always a point that I want to make to people that yes, we have good set of behavior from a waste management or practice, but it's bigger than that. So going back to your good garbage, we blame material a lot. So everything comes to the material, but we forget about the behavior and the infrastructure. So I think anything that we are generating as a waste is actually has a value. So whether it's anaerobic digester for that energy, and think about, the economies that are limited in their energy access, and most of the time they use a lot of food waste. That's a big chunk of energy that is lost to the environment. Um, so I think a good garbage is basically it's our responsibility to eliminate it, work as a society to develop the technologies to take it back and create value out of it. Because remember, it was not only the technology, but also the business aspect of making sure that recycled material is commercial to become sustainable. So, so yeah, I wanted to move the the question from the material itself to the system. It's the system that needs to take a look at the waste that we are generating. That's a great question. It's a tough one.
No, thank you. Thank you, Mounir. This has been such a fascinating and illuminating conversation for me personally, and I'm sure
Well, thank you.
anybody who would listen to it. And I think more than anything else, what has influenced me is your personality of looking at things at a very kind of basic and a level of understanding which can enable a solution to emerge. And I think that probably comes from this strong grounding in biology and microbiology, which has been fascinating right from the time when we started doing our research on you and Eastman and to our conversation now. So thank you so much for being the person you are and the kind of things you're doing. And we wish Eastman and you a lot of success. And I look forward to having many more conversations with you. Thank you so much.
Thank you, Van. A huge opportunity. Appreciate that and the question and the discussion. I hope we can do it again, maybe face to face. So thank you for that.